on this computer. Okay, today we have, I think, a very interesting presentation. It's all over the place. It's about ChatGPT, generative AI, and many related issues. So forgive me that there is no single idea or single topic in this presentation. You see there is a big list of things. This is me. Well, you all know me. I have many years of experience. I used to be in science. My current interests are crypto accounting because of the company Bixbeta, when I'm CTO and co-founder. It's a startup. But also in this seminar, we had presentations about cloud architecture, financial technology, application security, generative AI, data science in general. And you can find me LinkedIn, GitHub, YouTube, Google, very easy to connect. So AI is growing very fast, especially with new generative technologies and ChatGPT and similar. So you see it's more than 1,000% over year. And here are some terms which you probably know what they are, but it's actually interesting. People say generative AI. When I ask them what it is, they cannot tell. And it's very simple. Generative AI, it generates new content, right? It may be, it generates text, it maybe generates image. Hold on a second. Okay. LLM, large language models. ChatGPT is an example of a large language model. Hi. GPT, generative pre-trained transformer. Transformers, they name transformers because they transform something into something. Like, for example, text into another text, like Google Translate is an example. And in fact, the first transformer was, in fact, Google Translate, and the famous article, "Attention is all you need." ChatGPT, you know, it started in November last year, chat, web-based application. Foundation models. Nowadays, you will see these are big models which are generic in nature, and they perform like a brain in the middle of some other system. And AGI is artificial general intelligence. That's, we hope we'll see it in maybe 5-7 years from now. Okay. Systems with brain in the middle. So how humans operate? Well, there's a brain in the middle, there are some sensory inputs and some outputs, decisions, movements, and brain is very generic system which can learn and change. Baidu CEO Robin Lee says, foundation models have condensed human understanding of entire world, showing us the path towards achieving AGI. So foundation models are big models, like, for example, GPT model. Here is an interesting parallel or comparison. More than 30 years ago, I participated in designing a portable myograph. A myograph is a device to measure electrical signals. This is me, by the way, from, let's say, humans, from muscles or nerve fibers. And this is on the left, a big prototype. It's a very big and heavy and expensive device with a lot of custom electronics in it. All the amplifiers, filtering, and so on, all the programs are custom made. So it's inputs, then custom electronics hardware, and then output, right? What we did, again, we have to have inputs and we have to have outputs, but in the middle, we put a computer, and all the customization is done in software. So computer is much more complex than this custom electronics in this device. But if computers are mass produced, they become cheap, and actually this device was a big success because of that, and very customizable. So we see the same now with machine learning. When you have a classical machine learning model, you go from data to some custom function to some action or decision. So for example, the function may be to draw the line through the points, and after we train it, we identify slope and intercept. So our model, our function is simply ax plus b, which is a straight line, and then given x, we can predict the value. So this is hardware like wired, right? Whereas modern systems, what we're coming to, again, from data to some action decision, but in the middle we put a big model, which has billions of nodes, which behaves like a brain, is generic. It can answer multiple different questions. It can do a lot of stuff like ChatGPT, right? So it's like a brain. So we go through from hardwired system to a generic system, what's called foundation models, because this generic system may be brain, maybe the middle of many, many systems. The model itself can be without language. Like for example, baby or an animal, they can learn even if they don't have language. Like let's say small baby doesn't have a language yet. The foundation models can also be without language, or they can use language and can handle multiple topics. So it's more like adult. Okay. Plugins. This is a new thing. OpenAI released plugins to public on May 19th. And I want to make this parallel. For iPhone, we have App Store, which has about 2 million apps in this App Store. Android system, they have Google Play Store, and it has 3 million apps. ChatGPT was released about 2 weeks ago. Plugins were released about 2 weeks ago. There was 3 plugins from OpenAI, and then about 70 plugins from other developers. So it was on May 19th, and it was about 70 plugins total. I just checked, it's already about 200, and the number grows very, very fast. So I will not be surprised if we have huge number of applications, well, plugins, extensions, which use ChatGPT in the middle like a brain. Already you can just search and you will find people say, well, the 10 best plugins, the 70 best plugins, and how people improve and make more effective their daily work using these plugins. So plugins which come from OpenAI, well, the first most useful, which I started using, allows you to browse internet. There are plugins to read PDF files, describe the images, access third-party data in business, like for example, travel site or buying something. Okay, so this is about plugins. Next, tree of thought prompting. Okay, this is a very interesting idea. So there is an article which is called Tree of Thoughts, Deliberative Problem Solving with Large Language Models. Very interesting. I want to focus your attention on this last paragraph. So they used this big system to play a game of 24. ChatGPT with a chain of thought prompting only solved 4% of tasks. Our method achieved a success rate of 74%. You see, it's a huge, huge improvement. And there is open source and description, and I refer to this article. But the thing about something like ChatGPT, you give it some text, some prompt, and it will respond, right? That's what it knows how to do. But it's not very good at actually structuring the knowledge, and it may have some hallucinations. And it's mostly just you give it text and ask what should be the next word, right? So ChatGPT is just more complex, and it seems like it's intelligent, but it's not. It's lacking the structure. But you can lead it with the prompting in a structured way, and suddenly it can solve more complex problems. It can create more structured, I don't know, it can write a book for you. If you start with, give me the topic and then give me the 10 most important ideas kind of about this topic. So give me the table of contents for this book, and then for each of those chapters give me like 10 sub-chapters, and then write about them, and you'll get the book. So you need to add structure, because ChatGPT by itself doesn't do it. It has to be led by hand, so to speak. Okay, thinking in science, finding patterns in data. Okay, so science is about finding patterns in nature and describing them, often using formulas. Machine learning is doing something very similar, finding patterns in data, store them as formulas, vectors, or networks, and use them to do predictions and optimizations. So machine learning, well, similar to science. Now, suppose you invite a consultant, a talented, smart person, to figure things out. Like, a consultant can look at your situation, consider the facts, weigh them against each other, make sense of them, propose explanation, description, and suggest course of action. Modern large language models can do similar things, so very close to it. They can summarize the data, list main ideas, give advice. A talented general can and should see the big picture of the battle. A high-level manager or politician do the same thing. The word inauguration comes from the word augur, right? And an augur was a priest or official in ancient Rome and some other places. The main role of augur was to interpret the will of gods as seeing natural phenomena. They were elected officials, high level, and it's very famous. I actually recommend you to Google or ChatGPT about augurs, and like Julius Caesar was an augur. So modern large language models strive to become modern augurs. They soon may evolve to become our consultants, advisors, and managers, as they will learn to figure things out. Somebody is not muted. Please mute yourself. How ChatGPT runs Microsoft AI supercomputers? Well, OpenAI spent hundreds of millions of dollars to build infrastructure. Well, actually, Microsoft, well, I don't know, like it's between them, but it's a huge amount of money. And it's mostly based on NVIDIA latest servers. So here you see NVIDIA CEO autographing one of the NVIDIA servers. They use this NVIDIA DGX systems with 8 powerful GPUs in them, and these are some technical characteristics. I really recommend this video. This is by Mark Rusinovich. He is Azure CTO, and he describes in this video what they have built, the structure for OpenAI, and it's absolutely fascinating. Well, first of all, it's mostly NVIDIA. They running those thousands of servers in multiple data centers. They using NVIDIA GPUs, NVIDIA switches and links. It's all different hardware. They do clusters, and they do virtual clusters, because they need to be able to move and distribute the load to run huge models. They need to deal with failures, so they have a management layer. They have system to allow parallel training, right? They have this Project Forge for managing checkpoints and GPU utilization. Very interesting, very clever system. If it sees that GPUs are not used, they return them to the pool, and some other parts of this projects can use them. Checkpoint and restore user space, LoRa. So as you do training, which may take a month, right? You don't want to suddenly lose the data because electricity went down or network or something happened, right? So they have this checkpointing and restore system. It's really ingenious, and it's heroic what they have done. I really recommend this video. Okay, customizing the model, fine-tuning versus embeddings. Well, fine-tuning is the following. You take a pre-trained model, which has hundreds of billions of parameters, which was trained on terabytes of data, the whole internet knowledge, and you try to add a little bit of your custom data, kind of try to overpower, and of course it's not possible. And the system, although you provided your own data, but the system still has this terabytes of data knowledge, and it will, when you asking it question, you expect it to answer about the specific situation, but it will start involving all this other knowledge and start hallucinating and inventing stuff. So fine-tuning is not really very effective. Embedding is a little bit different story. Embedding, you can think about embedding as a wrapper around your model. Please mute yourself. Somebody is not muted. Please mute yourself. So embedding is a way to let the model search in the database and return the best result. So it's good for finding something specific. So how it works? You give a prompt to the system. The system first takes this prompt and converts it into a vector. Then it looks for similar vectors. You provide a database of vectors. So suppose you have a database of, let's say, products. You have online store, and each product is represented as a vector of features. Well, whatever. It may be some latent, hidden representation which the system, after training, decided to use. And when you get a prompt, you convert it to vector. Then you use special system which is called vector database, which can very fast look through all the vectors and find the nearest, the most similar vectors in the database. And then it may return it to you. And then what you do, you convert this vector into text, and you add this text to the prompt. So you modify your prompt by using some database, and then you feed this into the system, and then it will, of course, concentrate on the subject you really wanted to concentrate on. So you can modify the input, but you can also modify the output. Okay, here's an example of getting embedding using OpenAI API, and it's very, very easy. And this is the output. And you see the embedding, it's a vector. It's, well, here you don't see all the, but it may be 100 or whatever numbers in a vector. So knowledge represented as a vector. Embedding is a vector, numeric vector. Okay. Some recommendations on recommendations. You can do recommendations using embeddings. Okay, and this is example how it looks. All this you can easily learn if you just go to OpenAI documentation, GitHub. So this is specifically about embeddings. There is cookbook, which is great, and many examples how to use them. Okay, next is approximate analysis, similarity search in vector databases. I tried to describe it to you, maybe not very successfully, but you go from data to embedding vectors and then to similarity search. So this is kind of, you compare vectors, if they close to each other or not, and you can do Euclidean distance, cosine similarity, dot product. Okay, vector databases. So these are becoming very popular today, and there are multiple databases. These are, well, the most common you can hear about. They're here on the top right, and there are more. And there are startups getting hundreds of millions of dollars. I mean, this is like very fast-growing area of both research and business and open source. So we have exponential growth of vector embeddings in different like NLP, computer vision, generative AI, and vector databases are used to store and query vector embeddings. So it's kind of long-term memory for AI. They have features typical for regular databases, which is inserting, deleting, updating, metadata storage, scalability, real-time updates, backups, integration with ETL systems, data security, access control, and so on. So these are real databases, but instead of storing tabular data like regular tables, they store vectors, and instead of querying columns and rows, they are querying vectors, and they do not concentrate on exact match. They concentrate on similarity, like find nearest neighbors. That's the task. And there are, well, three main similarity measures: cosine, Euclidean distance, and dot product. Since vector databases provide approximate results, the main trade-offs are between accuracy and speed, right? And there are some, this is good article explaining, it's pretty lengthy, but it's good, like popular, explaining how vector databases work. So the list of databases, and this is a nice video explaining vector database. Okay. Next is on the path to artificial general intelligence, animals versus humans. I used to have an iguana, and when I spoke to my first professor, Boris Khodorov, when he was visited US, his first question was, does iguana have a soul? Well, reacting, yes. Learning, yes. But does iguana have self-awareness or thinking or language or consciousness? Well, I don't know. It's complicated questions. I know that learning doesn't require language. Like, for example, a baby, before he or she understands language, learns language, they still can learn, right? And also, deep neural networks, they can learn without language. Right? And for example, you can make a classifier to classify cats and dogs, and there's no language there. There is just some hard-coded connections, learned weights in the system. Do animals think? Well, some animals have language, like, for example, whales and dolphins. Even bees, which are insects, right? Honeybees, they have their own language, which they express in dance. I mean, it's really interesting. So most animals probably don't have a language in the sense we do, with words, and but they still can communicate, learn, and act. And this is an active area of research, and there are many, many books on Amazon. Owner said meow, he understands my language. Okay. Next, the origins of language and consciousness. Well, these are two topics people were thinking about for, well, tens of years, I would say hundreds of years, I don't know. My mother wrote a book which was called Origins of Language and Consciousness. Maybe that's why I'm also curious about it. I asked ChatGPT about origins of language, and that's the short answer. And also asked about origins of consciousness. Okay, transitions. So what we see happening is that we go from tabular data, tabular labeled data, to big unstructured data. So modern systems, these big language models, they can consume and learn from tens of terabytes of information, which is all unstructured and huge. We go from exact calculations and exact matches to approximate calculations and similarity search. We go from tabular SQL databases to vector databases, and from hardwired specific systems to generic brain-like systems. Okay. Next topic. I really like Andrew Ng, remember Stanford professor who co-founded Coursera and who popularized deep learning and has great courses on DeppLearning.AI. And they recently made several courses, the building system with ChatGPT API, ChatGPT prompt engineering for developers, a LangChain for large language models application development, and how diffusion models work. So you see these 4 courses, and for now they are free. All deep learning AI courses are top-notch. So this, when the first course appeared, it was my top recommendation, and I recommend if you want to get into these, just get these courses because right now they're free. I want to talk about Emad Mostaque. So he is in London, and he created a company called stability.AI, and he basically created stable diffusion. So stable diffusion is a deep learning model which is text to image. It was released about a year ago, and the systems which we know which generate images from text, they use this approach. His philosophy, his previous company was a non-profit. This company, I think it's not non-profit, it's a startup. They received more than 100 million in funding. They have about 170 people. They're growing very fast, but they're completely open source. He has very, very interesting philosophy of what he's doing, and he wants to go big and he wants to go public. I recommend to learn more about his company and about him personally, amazing person. So this is Wikipedia article about stable diffusion. This is GitHub where stable diffusion model is. And there's a lot of examples. If you just Google stable diffusion example and then whatever keywords you like. So for example, I looked for Van Gogh, and this is one of tens and tens of different examples which you can find generated by the model. Two most famous and frequently used systems to generate images are DALL-E 2 and Midjourney. So they both use diffusion model. Well, they both use some sort of transformer. So for DALL-E 2, it is GPT-3 language model, where it's OpenAI, and diffusion model based on Big GAN, which is Google. GAN is generative adversarial networks, and GANs are famous for creating images. Just to remind you how GAN works. GAN consists of two networks. It is like creative, let's say criminal, which tries to create something like a banknote, and then there's a policeman, discriminator, who learns to discriminate whether it's a fake or it's a real thing. And as they go back and forth, they both learn, like creative network learns to create better and better fakes, and policeman learns to discriminate better and better. GANs are amazing. There was a website, This Person Does Not Exist, which shows high-resolution images of people, and these people never existed. They were generated by the creative network of a GAN. These models, so first you give text, and you need a text model to convert a text into some internal vectors, and then from those to convert in using diffusion model to convert it into image, right? So DALL-E 2 and Midjourney, similar approach. It uses GAN, right? Generate realistic images, is using transformer to work with text. And then they use many other systems, like, for example, improving resolution, transferring style, colorization, synthesizing different textures, and so on. But there are two main models I just want to repeat again. There is a language model and diffusion model. So these are two very famous. We never had at our seminar a talk about diffusion model, so we probably need to do that going forward. Okay, detect LLMs. This is interesting. Apparently, there are multiple tools, and this is the list of tools, and you can just go to this link and read the article. So there are tools which can detect whether the text is original or it was created by, let's say, ChatGPT or Bard or Claude, some other system. So it's interesting. Okay, I'm at the end of the presentation, so I want to thank you for your patience, and I'm stopping sharing. I'm stopping recording.